Guys, hope all of you are doing great out there. I'd like to welcome each and every one of us to my channel of Honest Sciences and Mathematics TV channel. In today's discussion, I'm going to look at an interesting concept of the concept of bioinorganic chemistry. And this basically is going to be a broader topic that is going to entail various areas that we have looked at, especially under the concept of organic and inorganic compounds and, of course, substances. Now, in this case, we shall look at the close relationship between the two, and that is going to assist us, in a sense, try to appreciate this specific aspect of bioinorganic chemistry and some of the application areas which we are going to be mentioning in our subsequent videos. Now, in this particular case, I'll look at the basic, of course, knowledge that we had done from our introductory part to the concept of organic chemistry. And I'd say that basically chemistry can be divided into two broader categories of organic and inorganic chemistry. Now, in a sense, we're going to be seeing that these two specific branches are going to be differentiated using a range of elements, whereby we say that from basic definition, an organic substance is a substance that is basically made up, or we can just give this one in a summary form. So an organic substance is a substance whose structure is made up of a carbon and hydrogen. And as well, we're going to see that we can just give a different version of this specific definition by giving it as a combination of a carbon, hydrogen, or a carbon bond given as such. So in our introductory part to organic chemistry, I had basically stated that the element of carbon is going to be displaying a various range of characteristics, especially in its specific covalent nature of bonding with other substances or elements. And this is going to be due to its unique characteristics in trying to form different types of compounds, which range from complex, as we said. Of course, it's going to be forming some of the chiral compounds, and it's going to be forming some of the chains and rings, and in a concept that we said is catenation. And of course, among others, we are going to see that it's going to be displaying its various range of properties through the formation of various covalent bonds with other elements. Now, in a sense, we're going to be differentiating this specific concept from inorganic chemistry, whereby we're going to see that a substance is going to be defined as inorganic if the substance is not made up of carbon in its structure. So basically, it's going to be the opposite of the above, but we're going to see that there are going to be some of the exceptions which we are going to come across, especially which is going to assist us to differentiate between the concept of organic and inorganic chemistry, in a sense that if we try to consider the oxide of carbon and nitrogen, therefore, this is specific, of course, compounds are not going to be referred to as, of course, organic compounds. And of course, we had just elaborated on this specific case in our particular discussion on the concept of organic chemistry. Now, in a sense, we have differentiated between these two specific concepts. And therefore, in order for us to look at this particular aspect of bioinorganic, it's going to be a combination of two terms, which is going to be given as bio and inorganic. So basically, we're going to be relying on this specific set of substances which have basically defined as inorganic and bioinorganic, which is going to be assisting us try to understand this specific concept. And therefore, we shall look at a range of substances which are going to be assisting us in trying to differentiate between bioorganic and bioinorganic. And we have come across these specific substances in some of our discussions, especially on the concept of proteins, carbohydrates, lipids, and of course nucleic acids. And this is going to be consisting of a range of these specific bioorganic so we can just give this one in terms of perhaps bioorganic molecules. So for us to differentiate between these, we can as well have, so this is going to be bioinorganic molecules. We can just give a simple set of these specific two sets of molecules for us to understand the difference between the two. And this is going to assist us in trying to, of course, pinpoint basically what range of compounds which are going to be falling under our specific topic of bioinorganic chemistry. Now, basically, we're going to see that from our previous studies, I mentioned that this is going to consist of compounds which are bioorganic molecules such as carbohydrates. And these are compounds that consist of a carbon, hydrogen, and oxygen in their specific structure. Of course, we talked about proteins whose main building blocks are amino acids, and of course, we talked about lipids, and perhaps we can mention this last one for nucleic acids, which is going to be forming a range of these specific molecules that we can refer to as bioorganic molecules. Now, to contrast them from the lower one, we're going to have a range of molecules as well, which can be regarded as bioinorganic molecules. And this is going to be a range of molecules which are, of course, going to be contrasted from the first one by them being a set of molecules that can be regarded in terms of, so we can give this one in terms of a general set of minerals, salts, acids, which are going to constitute a range of these molecules. We can give a specific example like water, and perhaps oxygen, since we are going to be using them in some of our discussions, which are going to be particularly examples of what this specific, one of the applications of these specific topics, which we're going to come across in our subsequent discussions. Now, in a sense, this is going to be then therefore our point of concentration for trying to look at bioinorganic molecules, which are going to be taking part in chemical reactions, and basically this is going to be biased on the concept of biological systems. And therefore, that's going to be giving us, in a sense, a broader definition of this specific concept, or a comprehensive way of trying to understand these specific topics which we have given in terms of bioinorganic chemistry. And this one is basically a merger of two topics which we are going to see in chemistry, which is biochemistry and inorganic chemistry. Now, for the second part of this specific topics or a branch of chemistry, I've basically defined it in details in terms of a summary form. But for the first one, we're going to see that this basically is going to regard to these chemical processes which are going to be, of course, entailing this aspect of biological systems. And also, we're going to see that these are going to be chemical processes within and, of course, outside these biological systems, which are going to be basically influencing the activities within these biological systems. Now, in a sense, we had mentioned from previous videos that there are a set of biochemical processes which are going to be, of course, defining this aspect of biochemistry. And these are going to be, among other, of course, processes, the concept of cell development. The concept of cell development is going to be consisting of a range of chemical processes which we have basically stated in some of our videos, or the ones which we're going to come across. And this can include, among other topics, the concept of enzyme activity. So enzyme activity is going to be influencing this some of the biochemical processes which we're going to see. The concept of homeostasis, the concept of the cell membrane, or what we can basically refer to as membrane transport mechanism. Membrane transport mechanism. The concept of blood clotting or coagulation is going to be also involving this specific concept of this specific process. Now, I've mentioned the concept of oxygen molecules and water molecules as part of the bioinorganic, of course, molecules, which we're going to look at closely. And perhaps we can mention the concept of nutrition, and of course what we refer to as the minerals. Now, I've mentioned the concept of minerals in bioorganic molecules. So the concept of mineral metabolism is going to entail the aspect of these bioinorganic molecules. Now, this is going to be forming a set of what we shall look at in details, and of course how the influence of inorganic chemistry is going to be, of course, affecting these various processes which we have mentioned. And therefore, this is going to be creating for us a sense in which we can appreciate the concept of bioinorganic, of course, chemistry. Now, in our subsequent videos, we're going to look at basic examples which I've basically mentioned. And this introductory part is going to be assisting us distinguish between the various range of this aspect of bioinorganic chemistry by looking at the difference between organic and inorganic compounds. differentiate between bioorganic and bioinorganic molecules. Now we can categorize the various range of bioorganic molecules in terms of a set of three, which is going to constitute the bulk elements, the trace elements, and the ultra trace elements. And this specific categorization is, of course, given in terms of the demands or the requirements of these particular elements in our body or biological systems. And therefore, we can give different categories or just a series of categories which I've just mentioned in terms of element requirement in the biological systems in terms of bulk elements. And then we shall look at the concept of trace elements. And lastly, we shall look at the concept of ultra trace elements. And as I've stated, this basically is going to be categorized depending on the requirement which is going to be needed by the biological system. Or for instance, if I can specifically say our bodies, and of course, this is going to be given in terms of specific quantities. Now, there are various range of elements which we can give, particularly concerning these three sets of elements which I've mentioned, which are going to fall under the category of bulk elements, which can be given as elements which are required in our bodies. Now, for instance, we can give the example of carbon, hydrogen, oxygen, nitrogen, phosphorus, sulfur, sodium, potassium, and this is going to be magnesium and calcium. And if we try to look at this specific case for like a human body, I can just mention a few examples. I've mentioned the concept of course, carbohydrates, which are basically going to be molecules which are made of a set of these three specific elements of carbon, hydrogen, and oxygen. And this is going to be assisting us try to differentiate or rather appreciate the fact that these are going to be required in large quantities in our bodies. Now, if you try to look at this specific oxygen, we talked about the concept of amine, which is going to be basically forming the building blocks of proteins in our bodies, and therefore the combination of these two specific elements of hydrogen and nitrogen is going to be forming a basis for us in trying to appreciate this. Now, apart from this one, we're going to see that the combination of the first three and of course the phosphate molecules are going to be assisting us define the nucleic acids which we're going to come across in some of our studies, and therefore this is going to form a set of compounds which are going to be required in large amounts. Now, in cell physiology, I had mentioned that we're going to be having, of course, different charges on the surface of the cell membrane, and these are going to be affected by the presence of sodium and potassium ions, among others, which we're going to be mentioned, or particularly we have mentioned in some of our videos on the concept of cell physiology. Now, we shall look at the concept of magnesium and calcium, particularly, which is going to be, of course, be found in our bone structure and some of the body's tissues. And therefore, that's going to be giving us, in an essence, a summary of how these specific compounds are going to be, or elements are going to be categorized in terms of bulk elements. Now, therefore, these are going to be elements which are going to be required in large amounts in our body. And I've just given examples of what we are going to expect from the above examples. Now, for trace elements, we're going to have a set of elements which are going to be required in minute amount. And this constitutes of elements like iron, zinc, and copper, which we can just give as examples. And in that specific case, I can just give one of the examples of the first one, which we're going to come across in one of the processes which we had mentioned under biochemistry, which is, of course, blood oxygen transport in the body. And this is going to be especially be found in hemoglobin, which is going to be given in a particular example in our subsequent videos. Now, for the last one, we're going to look at one of the, or a few examples of these specific elements which we're going to come across. And this constitutes elements of manganese, cobalt, chromium, and then we're going to have vanadium, nickel, cadmium, and perhaps molybdenum. And this is going to constitute of a range of elements which are going to be required in very small amounts. And to differentiate between the two, so basically I'd say that for trace elements, these are going to be elements required in minute amounts. The first one is going to be required in large amount, while the last one is going to be required in ultra trace amount, perhaps. Now, for working of normal physiological processes of an organism, particularly I can give in humans of an approximately amount of 100 milligrams per day. And this is going to be the requirements that we can give under the concept of trace elements as per the body requirements. Now, for the last one, we can give in terms of 1 micrograms per day. And this is going to be defining the amount which is going to be required for the body in order for it to function optimally. Now we're going to see that for this specific set of inorganic elements to influence the activity of the body is going to be taking them in terms of course, a specific, degree. And therefore, we're going to see that the relationship between the abundance of this specific element in the Earth's crust and the requirement in the body is going to be basically differing. And therefore, that's going to be forming for us a basis for trying to describe some of the physiological processes which are going to be involved to ensure that basically these specific elements are found or available for the utilization of our bodies. Now, in a sense, we're going to look at a set of videos or a series of videos which are going to assist us understand deeper on the role of inorganic chemistry in biological systems. And therefore, we just going to be giving one of the I'm just going to be giving one of the examples of perhaps elements which we are going to come across that is going to assist us overall appreciate the role of inorganic chemistry in these biological systems. And this is one of the products which we are going to come across, especially in our conformational studies, or perhaps in our, of course, coordination chemistry. And this is the, of course, I can give an example of what we refer to as cisplatin. Now, this is going to be particularly an isomer, or what we refer to as a stereo isomer. Now, in our conformational studies introduction, I mentioned the concept of a stereoisomer, which basically constitutes of a compound that consists of the same kind of molecules, but the spatial arrangement is going to be different for the specific kind of atoms under reference. Now, for this one, we're going to see that this is going to be a compound that is going to be achieved from the formation of a complex of platinum. And this platinum is going to be having specific ligands, which basically are going to constitute the amine and, of course, the chloride ligands given as such. And basically, from our conformational studies, we can give this one in terms of a bit either cis or a trans. And therefore, as we can see, the orientation of this basically is going to be forming what we call a cisplatin given as such. So basically, this is a specific example of this compound is going to be given in terms of perhaps we can just give a name so that we are clear on this. So we're going to have this one referred to as diamine. So this diamine platinum dichloride, which can be given in terms of this specific, of course, arrangement given in terms of diamine. So this is going to be a diamine platinum dichloride given as such, which is going to constitute of isomers which have given in terms of the cisplatin, and of course we can give its partner in terms of transplatin given in terms of this central atom or the central, of course, a metal, which is going to coordinate between these specific ligands of the amine and the chloride given in terms of this one. So we shall have this one as the chloride and this one, and this is going to be giving us a trans. So in a sense, for us to be appreciating this role of inorganic chemistry, this is one of the inorganic, of course, compounds which we are going to come across. And this inorganic compound that is a diamine platinum dichloride is going to be what we refer to as a neo or anti-neoplastic agent. And this basically refers to as a cancer medicine, which we're going to come across. And this is going to be forming a crucial part of one of the applications, especially that we're going to come across in organic synthesis, which is going to be forming a relevant agent, which is going to be very essential for us in our day-to-day application, especially in the curing or, of course, handling the aspect of cancer, which is going to be trying to, of course, eradicate or trying to alleviate the condition of patients suffering from this specific condition. And as this is going to be creating, of course, a winding up sense of this introductory part to the concept of bioinorganic chemistry. And we're going to appreciate more of this specific topic. This concept is going to be assisting us try to focus on metallic systems assist us try to develop and understand the new industry and therapeutical products such as cisplatin, which I've mentioned, and of course, which is going to be assisting us understand, of course, the other range of products which we're going to come across. So kindly check our description boxes for various links of other videos. Engage us in the comment section, ring that notification bell, and also subscribe so that we can form a large community of members discussing this specific topic. So that is it for now, guys. Bye, God bless you. Catch us in our next video.